Hello and welcome back to another video in this Java tutorial series. In this video, we're going to be talking about something called object-oriented programming and how it helps us programmers to represent more complex information. Now, up until this point, we've been able to represent all of our information through very basic data types like strings, integers, and doubles. But what do we do when we have more complex information, such as all of the information related to a car? How do we represent all of that? Well, Java has just the answer for this, and it's through this thing called object-oriented programming and this idea of something called a class. Now, the word class here is synonymous with the word blueprint, and so what a class is it's all of the parts that would be required to assemble something. And in this case, it would be all of the parts required to assemble a car. Now, in the case of a very simple car, what we might list as the things required to assemble a car would be these very basic characteristics of maybe a brand, a model, and a year produced. We're going to ignore like the engine, the wheels, all of that. We're just going to look at like these very high level parts that would be required to assemble a very, very basic and very, very simple car. Now, even though we haven't discussed a lot here, only this idea of a class or blueprint and the characteristics required to kind of assemble a car, what we can do is we can actually start modeling this here in Java, even just with these very basic and simple concepts. And so in order to do this, we're going to go over to the lesson 4 folder over here. We're going to right click and we're going to create a new file, and we're going to call it car.java. Now, I'm going to get rid of this public keyword here just because it's not necessary, and we'll learn more about it later. But for the time being, what we're going to start out with here is just this thing here that says class and car. And so what we're telling Java is we're defining a new class or a new blueprint for what we are calling a car. Now, this part, the second part here, is just the name of the class here. So this could technically be anything, and Java would be fine with it. But we are just going to create a blueprint for a car. So this is going to be a car blueprint. Now, within this car blueprint here, we're going to list out the characteristics that we said would be necessary for assembling a car. And so in here, we're going to type out string brand, then we're going to type out string model, and then integer year produced. Now, these characteristics that we listed here are extremely important to helping to define a class, because these are the things that define what a car is. The brand, the model, the year produced, at least in a very simple case, all describe the things that would be necessary to describe what our car is. And these variables here have a special name, and they're called instance variables. Instance variables. And I'll explain this name a little bit more in the future. But the entire idea of these is that they describe the characteristics or the attributes of all of the information that should be tied to what a car is. Now, extending on this idea of treating this class here as a blueprint, if you imagine a manufacturer, a car manufacturer, such as like Ford or Honda, or any of these car manufacturers, what they have to do is they have to take this blueprint and they have to give it to like a manufacturing line. In this case, I'm just going to use a picture of a robotic arm to represent the things that assemble the bits and pieces of a car into the full car so that you can eventually have a fully functioning car. Now, what Java is going to ask us to do here is it's going to ask us to define this thing that assembles, what we are going to call the constructor. And so in order to define this thing that would assemble our blueprint into an actual object, in this case, turning all of the specs and things that we want in a car into an actual car, in order to do this in Java, what we need to do is we need to first list out the name of our class. And so we're going to go car, and then we're going to put 2 parentheses and some curly braces here. And this is how we tell Java that we are defining the constructor or the thing that is going to assemble a car here. Now, up until this point, we have only told Java the information that is relevant to putting a object together, but we haven't given it any specific information for any specific car. We haven't given it a specific brand, a specific model, or a specific year produced. And so what I have over here is just a list of some of Ferrari's different cars and models, and we're just going to choose one of these, and in this case, the 2023 Ferrari 812 GTS, and we're going to make our blueprint construct this specific model of car. And so over here, we're going to store in the brand, which is Ferrari, and then the model, it is the G12 or 812 GTS, the 812 GTS. And then we have the year produced, which is 2023. So now that we have defined the specific information relevant to the specific car that we want to create, in this case, the Ferrari 812 GTS 2023 model, we can use our constructor here to assemble this information here into an actual object now. And what you can imagine this looking like is we have our constructor here, in this case, our robot arm. And what it does is it takes all of the bits and pieces, in this case, the brand, the model, and the year produced, and it takes each of those and shoves them into this car object down here, eventually giving us a car that is constructed of a brand, a model, and a year produced, and whatever information that was stored in these containers when the car was assembled. Now, in terms of how Java does this, it actually does the majority of this here in the background. And so even though our constructor is empty here, what's going on is it is going through the brand, the model, and the year produced, and in the background it is packaging those here into a fully constructed object. Now, up until this point, we have only defined the blueprint for putting together our Ferrari 812 GTS, as well as the constructor to actually assemble it. But we haven't actually assembled any cars yet. We don't have a physical car we can interact with yet. So that's what we're going to do here. So in order to do this, we're going to go over to main.java, and over here we're going to type out car my Ferrari equals new car. Now, in order to break down what's going on here, I'm going to use a much simpler example that we've already seen many times. And so what I'm going to do is I'm going to create an integer container called number of dogs that stores the value of 5. So we're going to go int number of dogs equals 5. And then we're going to print out the information inside of number of dogs. Now, remember that whenever we list out the data type and a label here, this is creating a new integer container with a label with label being number of dogs. And so if I remove the value that's being stored inside of it, this is just a container. And when we do equals 5, we now store the value of 5 inside of our number of dogs container. But believe it or not, the statement down here where we're creating a new Ferrari follows the exact same process. In the first half of the statement, we're declaring that we're creating a new container that can store cars, and it has a label on it called my Ferrari. So it can store cars and it's labeled my Ferrari. And then we are putting inside of that container a new car. And this is great because now we can store this car that we generated here, this car that we created inside of our My Ferrari container. So this thing here is going to create the car using the constructor. And now that we have a physical car here that gets generated from this statement, we can then store that inside of our car container labeled My Ferrari. And so you'll notice this follows the exact same process as it did with our more simple integer container. It creates an integer container and labels it as the number of dogs and then stores some value within that container. And in this case, instead of storing some value, we are storing a physical object that we can now interact with. Now, I'm saying that this object is something that we can interact with, but how do we do that? And so what I'm going to do is I'm going to go sysout, and then what I'm doing here is I'm just typing sysout, and VS Code is able to convert this into the system.out.println statement. If you just hit enter, it'll automatically do that, so you don't have to write out the full thing. But if I print out my Ferrari and then use something called the dot operator, what I can do is I can access all of the relevant information that gets stored within our object. And so I can print out like my Ferrari.brand. And what you'll notice is it prints out the value of Ferrari. And above it, it has the value 5 because just up here we were printing out the number of dogs in the container up here. Now, one really, really important thing that I want to emphasize here in this lesson is that we are programming with the ideas of what something is. And so in this case, when we say myFerrari.brand, we are not actually doing anything with like the object itself. We are programming with the idea of what myFerrari is and what the idea of a brand is. And what I mean by this is we have no idea what information is stored within myFerrari or the brand. We only have the idea of what these two things are. So the reason that we can write out myFerrari.brand is because we told Java that, hey, this container that is labeled myFerrari is going to store a car or has the potential to store a car. And so then what Java does, at least on like the file side here, is it goes over to our car class and it checks, okay, so what information will we have access to if there is a car stored in this container? And what we have listed here is we have the brand, the model, and the year produced. So these are all pieces of information that could be tied to the car that could be stored in myFerrari. Now, I keep saying that there's the potential for our container here to store a car, and that's because Java doesn't guarantee that there's always a car within our container. For example, what I can do is I can use something called the null keyword, and what this does is it essentially assigns the value of nothing to our container. So what it would do is it would empty our Ferrari container. And you'll see that like Java's still technically happy. There's a warning here that this might cause an issue, but now because there's nothing inside of this container, when I run it, we get an exception. And the exception is it cannot read from the field brand because myFerrari is null, because there's no car in here to interact with. Now, this introduces an extremely important idea here to our program, and that is that how we program here in our file editor is very different from how Java executes a program. When we say we want to print out myFerrari.brand, we are programming with the idea of the information that could be stored in these containers. We're programming with the containers, not the information that is stored inside of them. However, the way Java executes this, when it executes like myFerrari.brand, is it executes it using the information inside of the containers. And so when we say myFerrari, Java interprets that as the car stored in myFerrari. And when we say .brand, it interprets it as the brand of the car inside of our myFerrari container. This is why our file editor lets us do what we're doing here. And once again, it gives a warning, but it still allows us to compile the code. And so what we're doing here is we're creating a myFerrari container that we are telling it it's going to store a car. But in the case that we actually empty that container, when we actually go to print this out, because we're programming with the idea of containers, this, like all of the code here, still works, or it still makes sense to us. Though how Java interprets it is that now because the myFerrari container is empty, when we go to print this out, there is no brand to print out because there is no car in the first place. Now, something that I would like to quickly explain before we move too far into the lesson is the explanation for why these things are called instance variables. And it's because when we go through the process of turning a blueprint into an object, when we use a constructor to assemble a new object, this new object that gets generated is what is called an instance. And so this thing right here, when we create an object, is called an instance of the car class, and it is the physical creation that came from a blueprint. And so now, because we call this thing an instance, the variables that are tied to this instance or this object are called instance variables. Now, the next thing I want to talk about in a bit more detail is our constructor, because I kind of gave a broad and like simple explanation of what's going on here, but I kind of want to walk through the process that Java goes through when assembling our cars here. And so if we go over here, what it does is it breaks this up into two steps. And the first step here is assembling all of our instance variables into our car object. And so this is step 1. Now, step 2 is going to be to run our constructor here. And what you'll actually notice here is that our constructor here doesn't actually do anything. And so what we could actually do is we could comment this out, and our program would actually still run the same way. And the only reason this is because if our constructor here doesn't do anything, or if we don't define one here, Java is going to just in the background create its like an exact copy of this where it's just going to be empty with nothing in it so that it can go through the process of assembling a car. However, if we define this constructor to do anything else in here, we can add additional functionality to our constructor. So instead of it just assembling the brand, the model, and the year produced into our car object, what we can do is we can do additional things in here, such as like print out information. So we can go sysout, and then we can print out additional information such as that we are in the constructor. So we are in the constructor and finished assembling our car. And we are finished assembling our car because that was the first step here. And we don't have to do anything else in the rest of our constructor. So if we go back to main.java and we run it, we get we are in the constructor and finished assembling our car. And that is going on in this statement right here when we are going through the process of assembling our car object. So if I comment out this second line here, what we get is just that assembly statement that we are in the constructor and we finished assembling our car. Now, being able to print out information as we're doing here can be handy, but Java gives us a much more powerful tool here to make our constructors much more useful. And that is this idea that we can pass in information to our constructor from somewhere else in another file. And so if we add another instance variable up here, and we're going to add the string color, and we're not going to give it a value yet because we're going to assign it here in the constructor. But if we just create another instance variable up here, what we can do is we can, here in our constructor, inside of the parentheses, tell Java that, hey, we're going to send in some information from another file related to the color. And so what that's going to look like is we're going to type out string color to assign. And so what we can do with this information that we're passing in here is we can assign our instance variable up here with the value that we're passing into the constructor. So if I go color equals color to assign, this is going to store whatever value we pass in here into our instance variable color. And so now you'll notice if we go over to main.java, we now have an error over here. And that's because the constructor car is undefined. And so what's going on here is that we define a constructor here that expects us to send in information about the color that we want to assign to the color of our car. And because we're not sending in that information here in our constructor call, this thing right here, Java is upset. So in order to make Java happy, what we have to do is we have to send in the information that our constructor here is expecting. So we want to pass in the color that we want to assign to our car. And in this case, we're going to pass in the value green. And so if we go here and instead of printing out the brand of our car, we print out the color, now what we get is the color green. Now, the reason that we can't use the default constructor like we were doing before, where we didn't pass any arguments, so where we didn't send in the value of green here, the reason we can't do this here, and I'll just change that so we get the one specific error here, is because what I said before with the constructor having a default constructor here, if we define any constructor that isn't just this empty one, Java is not going to fill that in the background. And so it just will not exist if we have any other defined constructor. And so we have to use the constructor that we define here in our class file. And so this default constructor that doesn't take in any arguments will no longer work. Now, to quickly recap what is going on here, we are creating a car container labeled My Ferrari. And within that container, we are storing an instance of the car class, which is generated by our constructor call here. And now this constructor call, what it's doing is it is taking in this argument for the color that we want to assign. And so with this value green, it's going over to the constructor in our car class, and it is passing in the value green here to the string container color to assign. So this string container color to assign is going to hold the value green. We are then assigning the instance variable color here with the value green that is stored within our color to assign container, so that when we go out and we print myferrari.color, the myferrari.color being the instance variable of the car myferrari, then we get the color green. Now, once again, I want to re-emphasize in this case that we are programming with containers. And this is extremely important, once again, because if we don't understand this idea that we are working with containers and information that could potentially be stored in the myFerrari container or the color container, we might get unexpected behavior. For example, if we go to our car.java class, in the first step here, when a car is assembled here, we are not assigning the value or the string container color with any value. Therefore, it's just going to remain empty. But we're doing it here in the constructor. Say though that we forget to assign a value to the color here. Java is not going to be able to recognize that, hey, there is no value stored within the color. So now if we were to do any logic here and we run it, we now get this value of null, which in many cases can lead to undefined behavior in more complicated programs, because we would normally be expecting myFerrari to have a color, and when it doesn't, this might cause bugs within our program. Now, the advantage of us assigning the color in the constructor is that now we don't have to hard code the value here in the first step of creating an object. We can do it here in the second step. And by doing it here in the second step, we can pass in unique information, such as different colors, to assign to different cars. Now, to show you what I mean by this, if we come back over here to our main.java file, what we're going to do is we're going to create a second car. And so what that's going to look like is we're going to do car my blue Ferrari equals new car. And we're going to pass in the color blue this time instead of green. And so when we go to print out the color of our car, we'll go myBlueFerrari.color. What we'll get this time is the color blue. Now, what's going on here is our constructor is still assembling the same car. It's still assembling a Ferrari 812 GTS 2023 car. These values are still the same for each of the cars. But now, by making our color of the car be a value that is passed in during the construction of our object through the parameters here, we can now choose the color of each of the cars via our constructor here. And so what this allows us to do is generate two different unique cars with their own unique attributes. And when I say unique, they're both still Ferrari 812 GTS 2023 cars, but now they each have their own unique colors. Now, taking these ideas one step further, instead of making all of our cars be Ferrari 812 GTSs and produced in 2023, we can do the same thing we did with the color here, where instead of assigning these values here in the first step of creating an object where we set up all of our instance variables, we can instead just set up the containers for the information that we want to store in here. And if I go through here and delete all of these, and instead what we can do is we can pass in all of this information here in our constructor. Now, what this allows us to do here is it allows us to do the same thing that we did with the color, where we can choose all of the information that we want to pass into our constructor to assign to all of our instance variables. And so what we can do is we can add in everything like the string brand to assign, and then we'll do string model to assign, and then we will do integer year produced, and then string color as well. And so we'll have 5 arguments to pass in here. What we can do is we can assign each of these variables here with the corresponding variable that we pass into our constructor. And so what that's going to look like is we'll go, I'm going to go over here so I can just add a line here, and we'll do brand equals brand to assign, then model equals model to assign, then year produced equals year produced to assign, and then year produced to assign, and then we can, and then that'll finish this off. So now what this is going to allow us to do here is it's going to allow us to do the same thing with these 3 containers as we did with the color container, where instead of assigning a value here in the first step when all of our instance variables are assigned to our objects that we're creating, we do it here in the second step of construction, where we now have access to these parameters so that we can send information in from other files and determine what the brand, model, year produced, and color will be from another file, rather than having to define it inside of our blueprint here. And so what that's going to look like here is we're going to pass in a string, a brand to assign, and then I'm going to pass in a string model to assign, and then the integer year produced to assign, and then the string color to assign. And so what we're going to do with this information is we're going to assign it to each of our instance variables that are tied to our car object. And so we're going to go brand equals brand to assign, model equals model to assign, year produced equals year produced to assign, and then color equals color to assign. Now, to really see the advantage here of using our constructor here to assign all of this information to our instance variables, we are going to create 2 different cars over here in our main.java file. So now over here in our main file, what we're going to do is we're going to type out car my newer Ferrari equals new car. And I'm calling it newer Ferrari because what we're going to do is we're also going to create a car that is from an older model of one of Ferrari's cars. And so with this, we are going to have to pass in the information that is required by our car constructors. We have to assign the brand to assign, or we have to pass in the brand to assign, and so it's still going to be Ferrari. And then the next piece of information we have to assign is the model to assign. And the model for this was the 812 GTS. And then the next piece of information is the year produced to it, which was the year 2023. And then the last one, we'll just do a red Ferrari. So we'll just pass in the value red, and we'll just capitalize it for the sake of capitalizing it. And so this is going to construct a red 812 GTS Ferrari produced in 2023, the same one that we had earlier when the information was set up during the first step of construction when we assigned our instance variables to the objects that we were creating. Now, to create our second object, what we're going to do is we're going to create another car container, and we're going to call it my older Ferrari. And we're going to call the constructor here. And what we're going to have to do is we're going to have to pass in the information relative to the older version of the car that we want to create. So we're going to hop back over to Ferrari's website over here, and we're just going to pick an older model that Ferrari has on here. And so we're going to go with the 2021 Ferrari Roma. And so if we go back over here, the brand is still going to be Ferrari. So we're going to pass in Ferrari. And then we need to assign the model. In this case, it is the Roma. And then the year produced was 2021. And we will keep the car red in this case. So now what I'm going to do in here is I'm going to put in a print statement to print out all of the information relative to both of our cars. So if I go system.out.println, and then we have the first part of the string here, which gets concatenated with the my newer Ferrari container and the color container of that Ferrari container, and whatever value is stored in that color container of our newer Ferrari. And we do the same thing with the rest of the information. So we can basically print out all of the relevant information in a very nice and legible way. And so what we have with the second statement is the same statement, just instead of accessing the color and the model and the brand of the newer Ferrari, we are now accessing the container of the older Ferrari. So whatever information is related to our older Ferrari. And what that looks like when we run it is we get the corresponding information for each of the cars. So this is a red 812 GTS Ferrari produced in 2023 for our first printout statement here for our newer Ferrari. And then for our older Ferrari, we have this is a red Roma Ferrari produced in 2021. Now, to re-emphasize for the third time, my newer Ferrari and my older Ferrari are just containers. What is important about them is not the information that is stored inside of them, but the information that the container represents. And that's because the information that is stored inside of this container can very easily change during the lifetime of a program. So if I go down here and say my older Ferrari gets into a car crash, and now my older Ferrari, to replace it, we just replace it with the same model as our newer Ferrari. And so if I do my older Ferrari, and we are just going to assign it with the same information that is stored in my newer Ferrari. And so when we go to print out the information, these two things are the exact same. So what wasn't relevant was the information that we first assigned to it. What was relevant is what the container represented, what the information that should be relevant to that container is. Now, the last thing that I want to talk about here is this idea that we could have multiple constructors. And so if we go over to our car.java class, I'm going to show you exactly that. And so if we type out the name of the class, those parentheses, and then the curly braces, what we can do is we can define a second constructor. And the benefit of this is in the case that we wanted a default constructor. So say we didn't know any of this information that we wanted to pass in when we created a car, what we can do is we can use a default constructor to assign default information. And so what we could do is we could assign the brand equals we could go through and come up with like default names for these. So we can go brand equals no brand, and then model equals unknown, and then the year produced equals we'll give it a default value of 0, and then the color we will say no color. So color equals no, put in strings, no color. And so what we could do is, if we don't know any information about the car when we construct it, we can call the default constructor, which will automatically assign all of our instance variables up here with these default values. That way they at least have information stored inside of them, rather than storing something like null, which could cause problems in our program. So if we come back over here and I go over here, and we just get rid of that other line I had in here. And instead of creating a defined car and my older Ferrari, what we're going to do is we're going to do new car, and we're not going to pass in any information. And so this is going to use the default constructor to assemble our instance variables into a car, as well as giving those instance variables their values here. And so when we print everything out here, it is our first print statement here prints out the car up here, and we get, this is a red 812 GTS Ferrari produced in 2023. In the second case, we get, there is a no color, unknown, no brand, produced in 0. And so that could be like our default car in case we didn't know any information about our car, as is indicated by the lack of information being sent to our constructor. Now, something else you could also do with this class is, instead of defining these default values here in your constructor, you could actually do it in the first step of construction when you create your instance variables. And so what we could do is we could go equals no brand, and then we could go equals unknown, and then equals 0, and equals no color. Now, the advantage of doing this is just that we can empty out our constructor here. And now, instead of just doing it in the constructor, we assign default values up here. And what I mean by default values is that in the case that any of these constructors don't give any of these things a value, they will already have a value stored inside of them, because during step 1 of assembling a car object, what we do is we set up our instance variables. And so each of our instance variables will be set up with one of these values. But when we come down to step 2, when our constructors are then enacted, if our constructors then reassign the information that is stored in, in this case, brand, with some new information, then these default values get overwritten. And so now if we call this default constructor down here, because these will already have default values initialized within our container here, when we call myolderferrari.color, it will just call the default values that are stored inside of the instance variables. And so if we run it here, you see that we get in our second statement there that default statement there. Now, something important to remember once again is that in this case, we had to define this this empty constructor. And Java would normally do that if we didn't have a second constructor in here. But because we do have a constructor with other types of information in here, Java is not going to provide its default implementation. So in the case where where maybe we normally wouldn't need this if we weren't to assign any values here in our constructor, we are now required to have this here in our file because Java doesn't give its own default version of this. And so we still need to specify this empty constructor here if we want to use the default values for our class. Now, that does bring us to the end of the lesson portion of this lesson. I know it's already pretty long, but this lesson does come with an exercise as well. And I encourage you to try out this exercise on your own, as once again, learning always comes from doing, especially when it comes to programming. So I'm going to give you a second here to look through this task.txt file here in the exercise folder, and I want you to go through here and try to complete the task at hand so that you can print out this statement here. All right. So now that I've given you a chance to go through and try this exercise on your own, I'm going to walk through the solution here. And so what my first, I guess I'll go through here and read this. In this exercise, your goal is to create a class for an apple this class should behave as a blueprint, allowing us to create many different types of apples using a single class. Our goal is to be able to represent the following: a Granny Smith, a Pink Lady Slipper, and a Honeycrisp. To accomplish this, you are going to need to create a class that can generically represent what an apple is, while allowing us to be able to uniquely identify which apple is which based on their unique attributes. And so our final goal here is to print out the following from our main method. So Granny Smith apple is green, has a sweetness of 4 and a tartness of 4. And so by the looks of it here, what we're going to need are a total of 3 unique attributes as well as a name attribute. A name for the apple, the color, the sweetness, and the tartness. And so these are all going to be things or instance variables that will be tied to our apple class. So I guess we'll just get started, and we'll go over here to our exercise folder, and we'll right click, new file, and we're going to type in apple.java because we're creating a blueprint for an apple class. All right. So within this blueprint, we need to first set up our instance variables. And these are all of the variables related to what an apple is. And so we are going to need the name, so string name. Then we're also going to need the sweetness, and we'll put the sweetness on a scale of like 1 to 10, and the same with the tartness. So int sweetness, and then int tartness. And then the last thing that we needed over here was, color. So we'll put that up here. So string color. And then the task wanted us to create a class that could generically reproduce different types of apples. And so in order to do that, we're going to use a constructor that will take in information from our main file over here. And so we are going to create our constructor. And so to create a constructor, it was the name of the class, your parentheses, and then curly braces. And then you fill in the curly braces with any information that you want to pass in. And so what we're going to pass in is name, string color, int sweetness, and int tartness. And what you'll actually notice here is these actually are the same name. And I'm just doing something that Java lets us do, and that's thanks to the thing called the this keyword. And what the this keyword does is it separates out variables that are being passed in from variables that are tied to the class. So when I type out this.name, that is referencing the instance variable version of the variable name instead of this local variable here that is getting sent in. So when I do this.name equals name, Java is fine with this statement. And so we can do that with the other values as well. This.color equals color. And then this.sweetness, sweetness equals sweetness. And then this.tartness equals tartness. And so when we create when we go to create our apple class, it's going to first start by, wait 1 second, constructor, I'm just going to label this here. It's going to first start by setting up our instance variables. And currently we don't have any default values in here, so it's just going to set up the containers that are related to our apple class. Then it's going to call our constructor down here, and it is going to go through the process of assigning each of these instance variables with the corresponding value that gets passed in here to our constructor. And so now over here in exercise.main, I'm going to just kind of delete this real quick, and we'll walk through the process of putting this in here. But we're going to create an apple, and we're going to go Granny Smith. We're going to name it Granny Smith, and we are going to create a new apple, pass in the name, Granny Smith, and then we are going to go through and we're going to put in the color. Control Z, green. Then we'll go through and do the sweetness, and the sweetness of a Granny Smith is pretty low, but we'll just go check our task file over here to see what it wants. So sweetness of 4 and a tartness of 8. So we'll do a sweetness of 4 and a tartness of 8. And then we're going to create our other 2 apples as well. And so I'm just going to copy and paste this. And then we're going to rename each of these containers to their corresponding apple, or what information should be stored in that container. And so we want a pink lady slipper and a Honeycrisp. So pink lady slipper and then a Honeycrisp container. Honeycrisp. And then for the name of pink lady slipper, we're just going to put in pink lady slipper. And then the color of these are pink. Sorry, VS Code is bugging out here with auto-filling in the name there. Sometimes that'll happen. You'll just have to go to like the last part of the string and then delete the part. But if we go in here and we pass in the color pink, and then the sweetness is, let's go check our task file here for what the sweetness should be. So 6 and 4. Oops. 6, 6, and 4, 4, and then we will define the attributes for our Honeycrisp as well. So this is called a Honeycrisp, and then the color is red with a sweetness of, let's see, sweetness of 9 and a tartness of 2. Sweetness of 9 and a tartness of 2. So now that we have all of our apples constructed, what we can do is we can create print statements to print out the information for each of these apples. And what you'll notice is these are each set up in the same format. We just replace each of these pieces of information that vary between each of the apples with the variable, or like the container that represents the information. That way we can keep like the formatting for everything that is in between the pieces of information that change. And so if we go back over here, we'll go sysout, and then we're going to do, I'm going to copy the line from over here so that we can try to match the formatting. All right. Paste this in here, and we'll just put a comment there so it doesn't cause any problems. And then we're going to do A, and then we'll put the name of the apple, GrannySmith.name, name plus the string apple, oops, yeah, is, and then we add the color, GrannySmith.color, and then string comment there, the comma there, and then has a sweetness of, and we list the sweetness, GrannySmith.sweetness, and then we could do comma and a tartness of plus GrannySmith.tartness. All right, and then we're basically just going to copy this and replace each of the containers that are calling the containers that specify the Granny Smith apple. We're going to replace the Granny Smith containers with the other pink lady slipper and the Honeycrisp containers, because each of those different containers stores the same type of information, just with different values. So we'll go through here and we'll replace the Granny Smith in this line. Oops. We'll replace it. We'll do the same thing with Honeycrisp. And then if we run this, we should get the same results that we want from our target output here. And so Granny Smith apple is green, has sweetness of 4 and a tartness of 8. And it goes through and it replaces each of the portions of information that are related to the apple itself with the information stored inside of a specific container. In this case, the pink lady slipper, or in this case, the Honeycrisp container there. And so we get the same output that matches here, thus completing our goal. Now, that does bring us to the end of our lesson here. As always, this lesson comes with a quiz, so I encourage you to go over and try that just to gauge where you're at. But with that, I guess we'll see you in the next one, and have a good rest of your night. See ya.